All right, today we're going to start with a warm-up. Why don't you convert the quadratic equation below into vertex form? Pause the video, attempt it on your own, and we'll go through the answer when you're done. Pause the video now. All right, so there's a couple of things you could have done here. I may accomplish this a little differently than you, but basically we needed to start out by either dividing by 2 or adding 40 to both sides. I decided to divide by 2 first. All right, so that changed the trinomial over here on the right side, so now my constant is negative 20. So I'm going to add 20 to both sides, and I've accomplished my first goal of getting x squared plus bx. All right, so now I can complete the square to turn this into a perfect square trinomial. So completing the square, divide negative 8 by 2, I get negative 4, and negative 4 squared is 16. So I have to add 16 to the right side and to the left side. Now I can factor my trinomial into a binomial squared. I can combine like terms, and now all I need to do is solve for y. Y is being divided by 2, and we're adding 36. So I'll subtract 36, and then I'm going to multiply both sides by 2. And now I have vertex form. Y equals a times x minus h squared plus k. And we know that the x-coordinate of the vertex is always h, which comes after the subtraction sign, x minus h. So the x-coordinate of the vertex is 4. And the y-coordinate of the vertex is always this constant sitting outside the parentheses k, which is negative 72. So our vertex is 4, negative 72. All right, let's try something a little different. Let's take a look at this quadratic equation. We've got y equals ax squared plus bx plus c. It's in the same form as the equation you just converted to vertex form. It's a standard form. All I've done is I've removed all of the coefficients and the constant. Now I'd like you to attempt to turn this into vertex form as well. Although we only have variables, the process is exactly the same. Let's see how far you get. So pause the video, do the best you can, and we'll go over the answer after you've tried it. All right, pause the video now. All right, let's see how you did. All right, so again, we could have started out two ways. We could have divided both sides by a to get rid of our coefficient of x squared, or we could have subtracted c. Now, you could have done either first. I'll show you what I did. So I decided to subtract c first, and then I divided everything by a. So y minus c divided by a, ax squared divided by a, and then bx divided by a. So this is what I end up with. At this point, I need to complete the square because I have x squared plus bx. So I'm going to take b over a and I'm going to divide it by 2 and square it. B over a divided by 2 is b over 2a. And when squared, well, we'll worry about that later. And I'll show you why in a second. So I've just written b over 2a squared on the right side. And since I added it here on the right side, I have to add it over here on the left side to keep the equation balanced. So now my next step would be to factor this trinomial into a binomial squared. Well, that seems difficult. But luckily, I always know that whatever I squared to create the perfect square trinomial is the term that goes into my factorization. So I've got x plus b over 2 squared. And if we multiply this out, you can try it. What you end up with is x squared plus b over a times x plus, and then you're going to multiply b over 2a by itself, or you're going to square it. And so this is the correct factorization. Now over here on the left side, I've simplified the term in the parentheses. We've got b over 2a, and we're squaring it. So if you recall, if you have a quotient raised to a power, then you raise the numerator to that power, and you raise the denominator to that power. So b raised to the second power is b squared, and 2a raised to the second power is 4a squared. And now Although this looks confusing, we're almost to vertex form. So all we need to do is solve for y. Y is being subtracted by c, and then we're dividing by a, and then we're adding this whole mess. So we're going to subtract this whole mess, multiply, add, and we should end up with a y isolated all by itself. So let's subtract b squared over 4a squared from both sides. Now this is a little tricky. We need to multiply everything by a. So y minus c times a is just y minus c. Parentheses squared times a would be a times the parentheses squared. And then negative b squared over 4a squared would be that times a, or a over 1, which would give us an a in the numerator, which would cancel out with one of these a's in the denominator, and that's why that little squared goes away. So now we're just one step away from solving for y. So we're going to add c to both sides. And now we have y equals a times x plus b over 2a, close parentheses, squared, minus b squared over 4a plus c. Whew! That was a lot of work. Was any of this necessary? Well, except for the fun that you experienced accomplishing this, yes. So let's take a look at what we've got here. So if you take any quadratic equation in standard form and solve it, convert it to vertex form, what you get is the following. And we know that in vertex form, the x-coordinate is always the value after the subtraction sign. And since this is an addition sign, this is x plus a value, we can reinterpret that as x minus a value, and that value would be negative b over 2a. Now, why is this important? Well, because we've proven, all right, that according to this vertex form, the x-coordinate of the vertex will always be the value negative b over 2a. This allows us to identify the axis of symmetry. And actually, this becomes kind of important if we want to find the vertex. Of course, we can always convert to vertex form, but as you can see, sometimes it's a lot of work. So what we can do is derive this little formula that'll help us get there. By identifying the axis of symmetry, we're going to be able to find the vertex in no time at all. Let's take a look at the lesson Finding the Vertex of a Quadratic Function. So here are two quadratic functions. How can we identify the axis of symmetry? Well, it's pretty easy to see that here the axis of symmetry is x equals 2. Now we know the axis of symmetry passes through the vertex. This gives us a very important piece of information, mainly the input of this function when the output would be, and in this case, because it's a sad parabola, the maximum value. So, all right, what is the output when the input is 2? The output is 1. That gives us our vertex. And now that we know the output, that also tells us the maximum output of this function. The axis of symmetry provides access to a lot of important information. Now let's take a look here. What is the axis of symmetry? All right, it seems to be x equals 1. That passes through the point 1, negative 4, meaning we know the input when the output of this function is at its minimum. The vertex is 1, negative 4. And since we know the vertex, we know the minimum output of the function. Now, what would happen if we didn't have a graph? All we had was what we know about standard form and our little derived formula for the axis of symmetry and a single function. What can we do with this equation to find the vertex? So again, we could convert it to vertex form. You know, if you want to do that, have at it. It's fun. But what we also could do is interpret the values of a, b, and c in standard form and plug those values into our little formula. Now, just like the quadratic equation, all right, I rewrite the formula using parentheses, and all I do is plug my values in. So the formula is x equals negative b plus 2 times a. And now what I can do is I can simplify that value. That's negative 4 over negative 2, which simplifies to 2. Now, I know the axis of symmetry. All right, it is a vertical line that passes through x equals 2. So, I know the vertex lies on the axis of symmetry. If the axis of symmetry is x equals 2, then the x-coordinate of the vertex must be 2. How can you use this information to find the y-coordinate, or in other words, what is the value of y when x equals 2? Well, all we have to do is evaluate the function for an input of 2, and whatever the output is our maximum or minimum. In this case, it'll be a maximum. And that's it. It's as simple as that. Oh, I'm sorry. So we identified the vertex and the maximum output. Okay. So let's try one on your own. So we know about standard form and the axis of symmetry. There is our function. Why don't you try to find the vertex and the, in this case, minimum output. So pause the video and attempt that on your own, and we'll go over the answers. Pause the video now. All right, so we identify the values of a, b, and c. We can plug them into the formula, simplify, and we see that the axis of symmetry is x equals 1. So we know that the axis of symmetry is x equals 1. How would we find the output if the input is x equals 1? We evaluate the function for x equals 1, and out comes a negative 4. So the vertex lies at 1, negative 4, and the minimum output of this function is negative 4. Let's try one more. Now, in this case, the graph isn't going to help us because the vertex isn't very neatly or precisely identified. So we're going to have to calculate it. We may think, or we can guess where it might be, but the only way to get a precise value is to calculate the vertex. So, take a moment, try it on your own. Let's see how you do, and we'll go over the answers. Pause the video now. All right. So step 1 is to use the formula to find the axis of symmetry, which determines the x-coordinate of the vertex. And so we identify our values of a, b, and c, plug them into the formula, and simplify, and what we get is 4/3 in this case. Notice I'm keeping this as a fraction because a decimal would be imprecise, at least in a calculator. All right, so we could also consider this to be 4/3 or 1 1/3. Both are perfectly acceptable. In fact, 1 1/3 might be a little bit more appropriate since we're trying to find this value on a number line. All right, step number 2 is to substitute the value of x into the function to determine the value of y. So let's plug in this 4/3. So when we evaluate the function for 4/3, if you go through all that and simplify, what you get is negative 3 1/3. So we have found the axis of symmetry. It is x equals 1 1/3. We found the vertex. That's 1 1/3 with an output of negative 3 1/3. And now we know the minimum output of the function is negative 3 1/3. And that, in a nutshell, is how you find the vertex of a quadratic function.